C'est sûr, on peut partir pour se défoncer. Ouais, qu'est-ce qu'il a rempli? Bah, l'autre côté du et en plus, tu regardes comment il part par là-bas. Donc, combien de temps le film? Je sais pas.
太淺啦，見晒底啦，你見晒底，啲水太淺，呢度已經乾晒。
1902 to develop, manage, and protect water-related resources. In 1956, the Bureau of Reclamation was authorized by Congress to build the Glen Canyon Dam as part of the Colorado River Storage Project, which includes 9 federal dams on the Colorado River itself and 11 others on its tributaries. Glen Canyon Dam was built for 3 main reasons. Those are water management, hydroelectricity, and recreation. Water management is important on the river because 40 million people rely on it for their water source. They need a constant, consistent supply. That is why the dams were built. The electricity produced here supplies just under 2 million people. That number changes a little bit depending on demand and lake levels. As for recreation, the third reason we built the dam, the area just around Page averages 4 to 5 million visitors every year who stop by to have some fun. Are there any questions?
Why do they have a coal plant in Page?
Before they built the dam here, this is one of the most desolate areas in the United States. It's still pretty rural, there aren't many communities nearby. They had the supply of coal in the area, but they had to build the plant close to a place that was already established for the workers to live. So they put the coal plant next to Page because the workers could live there, and that was also close to the coal mine.
It's just because of the coal mine is the reason?
Right.
Because you figure the hydroelectricity, they can shut it down.
Right, and we're on totally separate power grids. They send electricity south, we send electricity north.
Oh, I see.
How's the current lake level in terms of averages year to year? Like, is it pretty high right now?
We actually don't measure against an average because the lake fluctuates so drastically throughout the year. So most of the water we have comes in from snow melt in Colorado. If Colorado has a lot of snow, the lake comes up a lot during the summer. Last summer, Lake Powell rose 3 feet. That wasn't good for the water supply, but this year Lake Powell rose 50 feet. And that kind of change is very common. So we don't measure against an average just against full capacity. Today we're at 57%.
Okay.
Thank you for your question. Anything else? All right then. Guys, we're going to go down the hallway and look at the pictures. I will do my best to describe those. Correct. We could scoot down to the overhead, guys, and people can see. Thank you. All right. The first picture shows the Glen Canyon, what the area would have looked like back in 1869 when Major John Wesley Powell came through on the first successful expedition down the Colorado River. As he passed through Glen Canyon, he noted the smooth water, which indicates a flat bedrock beneath it, and the near vertical For these features, he recommended Glen Canyon as a potential dam site all the way back in 1869. When the project began in 1956, the first people sent out to begin construction were high scalers. They focused specifically on the canyon walls, where they put in dynamite to shape the canyon for the dam that was going to be built, and they put in rock bolts. The rock bolts are there for stabilization to prevent slabs of rock from falling down into the canyon. When you go outside, those will be the brown and green square plates in the canyon walls all around us. Before the high scalers moved out to this area, it was not populated. There's no city of Page, no Highway 89, no bridge. Those were all brought in to begin construction and for the workers. That's why they have this trailer hauled across the canyon using cable systems. The trailer was for the start of Page, which began as the world's largest trailer park. They had over 1,000 trailers for the workers and their families. Before the permanent bridge was built, 200-mile trip to drive from one side of the canyon to the other. It took them all the way across the Navajo Bridge. There was a temporary suspended bridge built for the workers when they needed to get across the canyon quickly. This was 6 feet wide. The bottom was made of a chain link fence. On top of the chain link fence, they put some plywood. The sides were made of chicken wire. You probably wouldn't have one of those bridges today.
And how high, when you were standing in the middle of that bridge, how high would you be above land?
The canyon here is just around 700 feet deep. Yes, so quite a way. A couple children from the time they would walk across the bridge, and they mentioned that the cars down at the bottom working, they look like little toy cars. It's just so far away. Bridge standing outside today, it was assembled from 1957 to 1959. It was first put together in San Francisco, California, lying on its side in a field. They did it there because they didn't want to put it together over the canyon, only to realize the pieces didn't fit together properly. They made sure everything worked as it should, took the bridge apart, sent it to Flagstaff, Arizona. From there, they shipped half of it to either side of the canyon, and then built it up to meet in the middle. And that's what the little picture up top is showing. And so far, we've talked about site preparation. This lasted 4.5 years. The last little bit of that was working down in the canyon with the river directly. They could not stop the flow of water at any time before, during, or after the project. So they used diversion tunnels, which took the water around the work site through the canyon walls. These were half a mile long, 40 feet in diameter. They allowed the water to flow while they were pouring the concrete. When the dam was finished, the entrances were sealed and rerouted to the top of the canyon to be used as spillways or overflows in times of flood. This is the desert, though. It does not flood very often. We only use the spillways twice. That was in 1983 and in 1984.
Wow. Particularly wet years in Colorado?
Yes. Particularly wet years, a lot of snow, but also warm springs. The snow melted very quickly.
Very fast.
We're going to go down to the next panel.
So we're still in the canyon wall?
Correct. Construction for the dam officially began on June 17, 1960, when they poured the first bucket of concrete. They poured 1 bucket of concrete every 5 minutes, night and day, for the next 3 years in order to build the dam. When they finished, they had poured over 400,000 buckets or 10 million tons of concrete. With that same amount of concrete, you could pave a 4-lane highway from Phoenix, Arizona, all the way to Chicago, Illinois. They finished the dam in 1963. From that time, they started working on the power plant, which they completed in 1966. When the project was finished, Lady Bird Johnson dedicated the entire project, and we do have a picture on the other side of the hallway if you guys would like to see it when you go by. Are there any questions? All right, then, everybody, we are headed outside.
So this is how thick, basically, the length of this hallway is how thick the canyon wall is.
The canyon wall, so the roads go very far in, yeah. You guys can head out to the first display.
Where's the...
핫띠 디저스. quality increase for Sam. Here's the bucket.
我说是原生来说是
原生的吧。
土墙
Just be careful, it will probably be hot. Yes.
钻出来这样。
We're right over here. This is concrete bucket number 6 of the 12 they used to pour the concrete on the dam. Each bucket could hold 24 tons or 22 metric tons of concrete. Every time they poured a block section of the concrete, they would allow the section to harden and then take out a round piece called a core sample, and that's what this display will be right over here. Each core sample was tested to 3,000 pounds per square inch. That's the strength of regular sidewalk concrete. They don't have anything special in the dam. The gravel for the concrete was excavated from Wallweep Creek, close to where Wallweep Bay is today, and the cement was brought in on trucks from Clarkdale, Arizona. A truck came in with cement every 40 minutes in order to keep the continuous pour going. Do you guys have any questions?
Is that an actual sample?
This is an actual sample, yes. This one is actually polished, the other ones didn't look quite so nice.
Where is this core sample?
This core sample is right over here. It's taken from the bottom of the dam.
So this, maybe you can explain a little bit more. So this core sample, every bucket was sampled.
Not every bucket, sorry. The buckets would fill in sections of concrete. The sections would be 7 feet tall, maybe 15 feet wide.
Okay.
And then each one of those, after it hardened, they would take out core samples.
So they knew that it was strong enough that it was mixed properly, et cetera. So this is an old core sample from during construction.
Correct, taken from the bottom.
Did they ever find samples that were good?
Yeah, so then they had to chip out the fire. No fun. All right, guys, we are going to move on to the next display right over here. I know it's hot, so we're going to get out of the sun as soon as we can. It was used in the power plant from 1965 until 2007. This turbine was replaced in 2008 with a slightly different model. This is made of cast iron and steel. The new turbine is made of stainless steel, and it has an extra blade in the middle. The stainless steel should help to resist the rust and corrosion, and the extra blade makes it 5% more efficient. It produces the same amount of electricity using less water to do so. They have replaced all 8 turbines in the power plant. Just for one, though, that was a 9 to 10 month process and cost $4.4 million. That did take them several years. It was a major project.
Wow.
When did they do that?
That was from 2008 to 2016, I think.
And the turbines are all basically beneath.
Yes, so when we saw it in the power plant, the turbines would be 2 to 3 stories below. The rest of the bolt goes into the rock anywhere from 15 to 75 feet. That is 4.5 meters to 23 meters, depending on where they are placed. The shorter bolts are at the top, and the longer ones are down at the bottom. We have high scalers even today who will continue to install the rock bolts. They have to do this because erosion continues to happen. They want to make sure the canyon walls are still stable.
Is there one that we could feel actually in place?
No, we don't get close enough to the canyon walls to do that.
The bolts basically made.
Correct. And if you come to the very end, it's the expansion joint, which they use to expand at the end to lock the bolt in place.
And that's the show.
Yeah, so this here is the end.
Okay.
This is the bolt.
Yep.
This piece at the end would be twisted on.
Okay,
And
so
then
like a knot.
this one expands. It's like a drywall screw.
Got it. Yeah.
Very big drywall screw. Are there any other questions?
How long is Lake Powell?
Lake Powell is 186 miles or 299 kilometers from the top to the bottom.
And what defines the top of the lake? Because I think about it, and I think it's just sort of a weird little blend between Colorado River. It's kind of ambiguous where Lake Powell begins and the Colorado River stops.
Yes, and it's kind of hard to determine. And with the different lake levels, the top of the lake does change a little bit. It's mostly where the top of the lake, where the river ends, the lake begins, it's when the water stops moving at a fast pace because we're still water. This cross-section display talks about the penstock tubes that are used inside the dam. The penstock tubes are these large water pipes used to carry water from the lake to the power plants out to the river. The entrances are 200 feet from the top of the dam. They descend 400 feet through the dam, where they level off to take water into the power plant before releasing the water into the river.
And are they tubes?
Yes, big tubes, 15 feet in diameter.
Okay.
Today, Lake Powell is at 57% capacity, at 78 feet or 24 meters below full pool, putting the water line just about there. Still quite a ways above those openings, so they can send water through and generate electricity as they need to. Just in case the water ever goes below the penstock tube, they can open the hollow jet valves. Those are bypass tubes located in the parking lot when we stop over on the other side. They're located near the base of the dam. Opening the hollow jet valves will allow water to go through, bypass the power plants, and continue down the river. 55 feet thick. When we stop in the dam, it's going to be 200 feet thick. Down by bedrock, it's 350 feet thick. So guys, go ahead, take your pictures of the lake. We'll stop here for maybe 5 seconds, and then we'll find some shade. We are going to keep walking. We're going to find some shade.
What are these rails out there? Is it like train?
Not a train, but it's a gantry crane. When we stop next, you'll see it on the far side of the dam. The gantry crane lifts gates away from the construction.
So there still is water in the Colorado River south of the dam?
Yeah.
Yes, they are constantly releasing water. So guys, we're going to stop right over here. Please get out of the sun and know it's nice and hot. When you are looking down towards the river, it is 583 feet or 178 meters from where you are standing to the bottom of the canyon. Glen Canyon Dam is 710 feet tall or 216 meters. There is a good portion we cannot see from here because they built the dam all the way down to bedrock. If you were to take the dam and raise it from the level of the bedrock up to the level of the river, the dam would stand 10 feet taller than the bridge. So this display right over here, this is for the cable systems they use during construction. That is a section of cable that they use to transport the concrete buckets and machinery. There are 256 strands of metal in each cable, but they had to replace them every 8 months because the buckets were so heavy.
And so the dam is 700, how many feet tall?
710 feet tall.
710. And the distance from the top edge to the river is, what did you say, 783?
583.
Sorry, 583. Okay. Got it. So the dam actually goes down below river edge.
Yes.
You know, yeah.
Thank you.
好，我们要进去了。
Guys, we're going to take one more elevator into the dam.
Like
Oh, outside? Yeah, it's hot. It's always hot. I think today is a little hotter than usual. Yes. That's expected. Did everyone notice the temperature change? And it's nice and cool here inside the dam. This is the natural temperature of the hallway. We do not have air conditioning. It is 55 degrees Fahrenheit or 12 degrees Celsius year-round, regardless of the weather outside. Because here in the dam, it's basically a man-made cave. There's 100 feet of concrete between us and the lake, 100 feet of concrete between us and the river. That's more than 30 meters in either direction.
So you're saying we don't want an earthquake to hit river?
That isn't a major problem. That's one of the reasons they built the dam here. There are no major fault lines. There's not a lot of movement. All right, guys, when you go down the hall, we'll pass 2 inspection galleries. These are there for you to see what the hallways look like and the rest of the dam. Don't stop too long, though. We're headed outside.
Oh, hungry. You going to the refrigerator?
Have you been inside a dam before? No, it's the first time. I'm not in Seattle, Washington.
Grand Coulee? Store some wine.
This grass.
Oh wait, that's grass?
This grass.
At river level.
Down there. Maybe they could have this spot.
Down below we have 2 acres of Bermuda grass. It is real, so they have to mow and maintain the lawn, and there is one gentleman in charge of that. He likes to mow the grass on Thursday mornings. It takes him 2.5 hours on a riding lawnmower provided by the Bureau of Reclamation. They don't make him push one around for those 2 hours. The grass is there for a practical reason, so people don't go down there to play sports. No soccer, no football, no golf. I know that would be lots of fun. But if you remember the penstock tubes we talked about above, down beneath the grass, they will stop their descent in the dam, level off, and take water into the power plant. That change in direction while they're carrying water would have caused the pipes to shake had they not been surrounded with dirt and gravel. The dirt and gravel absorb the vibrations, keeping the penstock tubes relatively still. They planted grass on top of the dirt to prevent dust blowing into the ventilations of the power plant. It was a simple, easy solution to their problem. If you're looking at the base of the dam, there's a hole with some water coming out. That is seepage water that has made its way through the pores of the concrete. Concrete is not completely solid. It is slightly porous, which allows some water to make its way through. They refer to this as seepage and not leakage because they expected it to happen long before the dam was built. It'll exit there at the base of the dam. There's a pipe across the way. We will pass another pipe when we go into the power plant. These all have seepage water coming out of them. Right now they're measuring the seepage water around 1,600 gallons every minute. That does not include the seepage water coming around the dam through the sandstone. Sandstone is 25% porous. It acts like a sponge, soaking in all the water it can, not necessarily releasing that water. But the black streaks on the canyon walls show you where some of that seepage water comes out. Yeah. So you're going to hear some water. That's the seepage water coming out of the pipe.
And seepage means that water's not getting used for anything.
Right. It's sort of like a bonus to the people downstream.
Not 100% watertight. Davey has to start the generator.
So this is the power plant. When you come in here, if you're looking through the windows, those are the 8 generators in here. Those are the yellow buildings. Today they are running numbers 8, 7, 6, 5, 4, and 3. That's quite a few. They only run 4 to 7 at a time with the current lake levels. Number 8 is located at the far end away from us, and number 1 is here closest. Each generator can produce 165 megawatts at 13,800 volts. The voltage is boosted to 345,000 before it leaves the power plant. That allows us to send electricity into the states of Arizona, Utah, Colorado, Wyoming, and New Mexico. We looked at a turbine at the very top of the dam. We're not looking at the turbines right now. Those are 2 stories below the yellow buildings. In the yellow buildings, you have a rotor made up of electromagnets and a stator made up of copper coils. The 2 pieces spinning past each other generate electric. All right, everyone, we have about 1 to 2 minutes in here to look around. You can look at the displays, ask me questions. There is a short video if you want to watch that. I'll let you know when it's time to go back.
The process of transforming the physical energy of falling water into electrical power is one of the technological wonders that has made modern life possible. As water rushes through the turbines underneath each of the generators you see in this power plant, the force of the water causes the turbine blades to spin the generator's rotor at 150 revolutions per minute. As the whirling rotor passes the stationary coils of wire that surround it, it creates an electrical current. From the generator, the electrical current passes to transformers just outside the powerhouse, where its voltage is boosted to 345,000 volts before passing through high-tension power lines to distant cities. Like all mechanical equipment, the huge generators must be overhauled and repaired from time to time. This is a major job involving closing the penstock gate leading to the turbine and careful disassembly of the entire unit. The large overhead crane used to lift out the rotor, turbine shaft, and other components can hoist 600 tons. Periodic inspection and maintenance of each generator helps ensure its consistent performance in producing electricity.
Yes, every hour.
Every hour.
All right, everyone, time is up. You have to go back to the visitor center now.
Because you told me this. So that water there is going into the river. Pretty impressive. Honestly. Thank you.
You're welcome.
It's kind of moist. Feels good in here. Doesn't it feel good?
Yeah.
That feels good.
Can you show me the inspection?
Fast border, not along the rail. Just come over here.
We're going to keep moving, guys. We're going to head down the top of the dam.
All right, from my group, we have another tour group coming. Please stay to the right.
It's toasty out here, y'all.
I thought we were close to a whole lot more.
Oh, no, you're not.
Access panels?
It feels sloped.
Yes.
It is not flat.